Hey, Akshay, how are you, man?
Hey Hugo, I'm good. How are you?
I'm well. Great to see you. I just emailed you just a heads up by a quirk of YouTube. The live stream has actually already started. So we're going
Hey,
live. Just to let
all
you know,
good.
we're going to jump in. And Carol Willing and Seth Tam have just said hi in the chat. And I actually corresponded with Carol yesterday on LinkedIn. She mentioned you two caught up at PyCon
We did,
recently.
yeah. That was a great experience.
Amazing.
Yeah, yeah. It was really good.
Um, and she
And
said,
probably at SciPy too. In
well, exactly. And I'm going to be at SciPy as well. So
fantastic.
it'll be great to meet IRL. So shout out to everyone who's tuned in so far. Hi, Hugo Bowne-Anderson here with Akshay Agrawal. Going to jump into all things about next generation of how we're going to build data, machine learning, and AI-powered systems into the future. Carol says loving Marimo as well. And I'm sorry, do I pronounce it Marimo?
That's what we say, Marimo. Yeah.
Cool, that's what I like to hear. And it's got some real algae vibes, right?
It does, yeah. Marimo is a type of moss ball that is like beloved in a lot of places, Japan and some places in Europe in particular. Cute little spherical things.
Super cool. So, firstly, welcome everyone. Welcome Akshay. It'll be great to know where you're watching from and what your interest in such things are or is. I'm currently in Europe. Akshay, you're on the west coast of the US.
Yep, I am. That's right, in
Awesome.
California.
Still incredible that we can jump on a call and stream to the cosmos. Um, everyone, this is a live stream for the podcast Vanishing Gradients. It's a data, ML, and AI, what we call AI these days, podcast. Please do Google it, check it out. It's on all the apps besides Tinder. We don't push it there. And give it a like and subscribe if you're into that type of thing, and give it a review if you enjoy it. If you don't enjoy it, don't give it a review. Just stop listening. But it is the internet, of course. Carol says she's dialing in from sunny San Diego. Beautiful. I'm actually really excited to be here today with you, Akshay, for many reasons. You're building Marimo. You have a PhD in electrical engineering from Stanford University, and have done a lot of Stanford. When you worked at Google, you worked on a lot of open source projects, including TensorFlow. And so one of the reasons I'm excited is you have such a diverse set of experiences to come in then and working on a tool such as Marimo in such a vibrant ecosystem that I really want to dive into all of that. I do want to set the stage by saying I kind of feel old, man. Um, and what I mean by that is like I came up not even using Jupyter notebooks. I came up using IPython before Project. I was using IPython notebooks, right? And I was using Pandas and Matplotlib and SQL, and these are still fundamental tools in a lot of respects. But I hear the kids are doing a lot of different things these days, right? Using Polars and DuckDB and Altair and Marimo. So I do want to find out about the next generation and what people may call future music of machine learning and AI tooling. So maybe with that having been said, you could tell me about where we are and where you think we should be with the tooling landscape.
Yeah, that's a great question, and I used to I used some of those things that you mentioned. So I did grow up on Matplotlib, and so you don't have to feel. I also feel old a little bit, but um, I guess so. There's machine learning tooling. There's like tooling for like working with data in particular. So I guess like the sort of the specific tools that you mentioned, it's actually kind of interesting. So. Um, I think we're kind of seeing this across the board in the open source ecosystem of like the old guard of tools and the new guard sort of emerging, right? So you mentioned TensorFlow, for example, which I did work on while I was at TensorFlow. Actually, while I was there, so I was working on TensorFlow 2 actually, which was making like TensorFlow more imperative, more PyTorch-like. But while I was there, there was this small Skunksworks project being developed on JAX, which is now sort of like the de facto, at least in research, especially at like in DeepMind and in Google, sort of the de facto tool. So like from TensorFlow, there was JAX, which adapted more of like a functional sort of declarative programming model. From Matplotlib, a lot of folks are using Altair now, again, actually, from a very imperative API, an extremely powerful API. I think some of the plots I made in my thesis I wouldn't have been able to do otherwise, but going from matplotlib to Altair, also more of a declarative paradigm. Going from pandas to polars, which also has more of a functional vibe going for it with its like lazy expressions. Um, a lot of the chaining also is a lot more declarative than just types of things you would do in pandas. And then some people say going from Jupyter to Marimo, and you might guess again, another sort of a bit of the pattern here is going from a traditional notebook where you sort of imperatively run cells, one at a time, and you have very fine-grained control over the state of your RAM, to a notebook that models sort of the data dependencies for you and requires you sort of code and think about notebooks sort of holistically as like assembling an actual program where like you run one cell, Marimo knows what other cells need to run in order to keep your code up to date. So I think and in order to use Marimo effectively, you got to code in sort of a bit more of a functional way, which we can talk about. But I think like maybe one common thread that I'm just spitballing, I just came up with right now across all these tools you mentioned is this sort of embracing of, data in, data out, functional style programming. Because if you embrace that, tools can do they can either like do like a lot more optimization, like what Jax does, or they can just kind of provide you more guarantees about the state of your code, what Marimo does, or they can just improve the developer experience. So maybe Altair does, and Polars does, I guess, both of those things.
I love it, and I love it how you like it is a data first and a data centric paradigm, and we'll get to this, and I think, but something I really appreciate about Marimo is essentially you have a DAG, a directed acyclic graph of cell execution, and it doesn't allow you to have loops, right? And that does respect the what we call the data flow paradigm, right? Which is incredibly important in our work in so many ways. Now, these are places I do want to go to with this conversation, but I do think we don't want to be too tool centric, right? Tools are here to serve us as data practitioners, and you have such a rich history. I'd love to know more, like with your work from Google Brain, when you're at Netflix, Stanford, across all these roles. Where did you see and consistently see ML, AI, and data workflows break down?
Yeah, that's a great question. So I guess I will caveat that by I had different kinds of roles at each of those three places. So at Google, I was just basically 100% on the engineering side, where I mean, I was sitting in Google Brain, but I was working on TensorFlow and TensorFlow 2. So to the extent I was watching things break down, it was typically more like seg faults rather than model drift, if you mean. So like I was working on computer systems there. Uh, at Netflix, I was working on um, a bit of like optimization research and like systems research. And actually that there's some interesting anecdotes to share there. And then at Stanford, it was pure machine learning research um, that was always grounded in like open source development. So I guess like that there's a couple of areas I guess where I saw things break down. Um, at Netflix, at least at the time when I was there, and this was quite a number of years ago, one thing I think that was common, that was a common source of frustration amongst the engineers there was actually just running batch jobs, like running um, like big data processing sort of workflows, maybe powered by Spark, um, because they had a lot of batch jobs to run and they didn't have basically they were oversubscribed. Their cluster was oversubscribed. So like scheduling was actually a big issue. So it's just like, like you engineers would tell me that like you would need to schedule your job at some arcane hour of the day to try and hope to hope that it would get, slotted in at, and actually run on time, like at 2:43 a.m. I don't know, I'm getting the details wrong, but like scheduling and making sure that the systems that were running the workflows that the data engineers needed run or the ML engineers needed run. Um, the system side of that was constantly a pain. I mean, at Google, that was pretty well developed as far as I understood. You could kind of just write your Borg CFG or whatever sort of configuration file and let your autopilot thing kind of handle the workflow scheduling. Um, but not as many places have as sophisticated systems as Google did back then. And at Stanford, the things I saw break down, those were of a different kind, right? So that was more of research. And so, we weren't at that stage where you had some cluster running some batch workflows. Um, but rather like things would break down in the beginning of the project and like ML project. And I think this is common in industry too, where like when you started working on your model, started training your model, you didn't take the time to set up like model checkpointing. Did you use Git? I don't know. Maybe you did. Where did the data come from? Well, I downloaded it and put it in this file in my directory. Um, and then a lot of this work did happen in like, the notebook of the day, these traditional sort of imperative notebooks. And when you do that, like you can write a lot of code quickly, but with traditional notebooks not enforcing like a data flow structure on your notebook, with traditional notebooks letting you run things out of order. I saw this really often where like, you would be iteratively programming in a notebook. You write some code in one cell, maybe you comment it out and you run another cell below, or you copy paste it uh, above and you start running these cells in this piecemeal order. And then you get some output saved in your plot. You do get something saved to disk. Maybe you forgot also along the way, did you keep track of the packages you used? Maybe you did, maybe you didn't. But at the end of the day, the researcher would have, okay, yeah, these plots look good. I have something saved to disk, which is my model weights. All right, I have a model. Then you pass that like notebook file to someone else. You didn't save the requirements. You ran your cells out of order. So like when I try to run your notebook, like I'm just gonna run it top to down, top to bottom, and then it often didn't work. And we can talk about this more, but I think this is the idea of like imperative programming notebooks or REPLs accumulating hidden state. And so that was like kind of a consistent theme that I saw and sort of inspired me to like take these sort of experiences that I had of like TensorFlow, where I thought a lot about data flow because TensorFlow was the whole thing was you're building a data flow graph. And like my PhD, where I saw a lot of folks like working interactively with data. And I saw that it was incredibly valuable to have a programming environment that lets you work interactively with data. But I also saw that there was a lot more we could do to ensure that the work that you did, the work that came out after you were done working in a notebook, was actually reproducible and reusable by others.
Absolutely, and I appreciate that rich history and you giving us so much context. I think before going any deeper into some of these things, could you just, for those who may not know, explain the difference between imperative and declarative?
Yeah, so let me see. I think a simple way to describe imperative is it's like a programming model in which you describe a sequence of instructions. You're saying what you tell the machine to do one thing, then do another thing, and then do another thing. Um, so and in contrast, declarative is you just say what you want and you don't specify how you want it, how that goal should be achieved. Um, and so I did my PhD in like mathematical optimization. So maybe this analogy will make sense. And if it doesn't, we can find another one. Um, imperative would be like you have some problem that you want to solve, like um, you want to uh, allocate stocks in a financial portfolio or something, and you want to get good return. So imperative would be like trying to like come up with some kind of strategy, on your own. Like, okay, maybe I should first buy some of this stock and then short this stock because I have some feeling that that would be a good idea. And then once that happens, then I should do this, etc. Like coming up with like the plan of investment on your own. Declarative in this context would be saying, hey, all I want to do is I want to maximize return and I want to minimize risk. Here's my mathematical model of what return means. It's an expectation. And here's risk. It's like a covariance. It's like a quadratic form on covariance. So here's my model, here's my constraints, and you tell the computer, hey, just go figure out what actions I should take in order to maximize return and minimize risk. So um, yeah, it's declarative is telling the computer what you want and not how you want it achieved.
Awesome. Um, I love that. And actually, firstly, we've got a bunch of people saying "Love Marimo!" exclamation point in the chat in YouTube. So that's super cool. Carol Willings made a really nice point. And we'll get here with respect to perhaps how this type of declarative paradigm is even more important in the world of generative AI. But Carol said explicitly, declarative works well with prompts, right?
Yeah. Yeah, exactly. Because you're telling the large language model this is what I want, and I prescribing a large language model how to do something I actually don't even right like it's not clear what its mechanism of doing things is at all, but you tell it what you want, right? And it'll hopefully go and turn away and do what you want it to do or achieve what you
Absolutely. And there are slight variations which maybe mix the two slightly, but I still think they're more declarative than imperative, where you say explain your reasoning or something like that, right?
yeah.
And quote unquote chain of thought stuff. But that's for another conversation. Thank you for spelling that out so much. So I'm wondering if you can share an example of a concrete workflow and workflow failure that's helped to shape how you think about reproducibility and collaboration in data workflows. And I'm just going to say, usually I say AI as something to encapsulate data, ML, and AI, but I prefer saying data because that's what it really is, right?
Yeah.
So, but I'm more comfortable in this conversation saying that. So, everyone, data means data, ML, and AI from here on in.
Yeah. Let's see. There's a few that I could talk about. Um, I'll guess one. Here's one that's like may feel kind of micro, but like I've seen like many times and kind of gets at somewhat to the heart of what we're what people appreciate about Marimo. And so I mentioned that like the reason me and my team are interested in working on this sort of new kind of notebook is that one, we see how valuable interactive computing is, and there's a reason like everyone uses Jupyter notebooks in order to first start exploring their data. But two, um, traditional notebooks where you can run cells single, one at a time, mutating the your global state that can accumulate sort of hidden bugs. And I can give one really one concrete example that again may feel micro, but I think I've seen like many times. And it's the idea of like in a traditional notebook where like the notebook doesn't have any understanding of how two different cells are related. You can delete a cell and that will remove the code from the page. Like you won't see the code anymore, but your variables will still live in memory. So if you were, I don't know, training some model and you deleted a cell that like declared some hyperparameters or something, and like maybe your cell was really long, right? So you weren't exactly, you didn't realize that some variable that you actually required downstream was defined in this cell. And then you went ahead and you deleted it. Your notebook will still work as you intended it to because that variable actually still lives in memory for the duration of that notebook session. But come back the next day and restart your notebook, that hyperparameter lambda or whatever that existed in that cell no longer exists on the page. It won't run. So when other code runs that assumes the existence of it, it'll just totally fail. And like it sounds trivial, but I myself have spent several hours debugging issues like this. And you multiply that across times the number of people who work in traditional notebooks for data, ML, and AI. Like these kinds of problems are like a real tax on developer productivity. Um, and so that's one specific thing that like Marimo kind of just solves out of the box for you. And so the way that Marimo works without going too much into the details is that like when you type code in Python code in your cells, it sees what variables your cell defines and what variables it references, and then it builds this data flow graph on it. And so that if you delete a cell, Marimo says, hey, all those variables should not be available to the rest of your program anymore. And it will actually remove them from program memory and then tell you, like, it'll invalidate other cells that depended on those variables. So, like, you catch your bugs immediately, basically before they actually have any deleterious effect. Um, and I think at a higher level, what our users kind of tell us is that like because of things like this that we do, like we eliminate hidden state, we store notebooks as pure Python, um, these notebooks actually end up becoming like reusable artifacts for the data person, the ML engineer, the data scientist, the data engineer, in a way that they didn't really have before. Um, and so for people who like traditionally kind of live in notebooks, like this is like a huge level up or like new ability sort of that they've gained of like essentially being able to write software sort of for the first time almost. And so I think like that reproducibility bit, and there's more we can talk about what we do for packages as well. Um, I
Yeah,
think
let me
that
stop you there because that gives such rich context, and I do. So yeah, I want to say I think I've been using notebooks but actually the first notebook I used wasn't even IPython, it was Mathematica before
yeah.
that in the 2000s, in the zeros. Um, but you know my background's in research science, in biology and physics and math, and I love notebooks. I love them so much because I think people who've worked in science and biology in particular know this, but the mental model comes from experimental notebooks where people will like take their PCR gels and stick them in an actual notebook and write notes next to them and have their little plots and put them there and you know this type of stuff. So having this in a computational environment, incredibly useful. Hidden states, being able to delete cells. I was triggered numerous times when you were talking through that. How many times I've opened like untitled 66666.ipy YNB on a Monday morning after being happy on a Friday late Friday evening. Absolutely brutal, man. Absolutely brutal. And you said hours in a row, like the amount of chaos I've caused for myself um, by not being rigid, and the flexibility of notebooks I've used are fantastic. But I do think you need structural rigidity imposed by the infrastructure as guardrails, which is what you're speaking to. And the fact that you mentioned if you delete a variable, it will let you know what's happening downstream because of that. Also, if you try to define something that you've already defined, it won't allow you to. It will very nicely offer you a scratch pad where you can do those things as well. And so these types of features, I think, are very aligned with the type of reproducibility we're talking about. Also, to your point, I was when playing around with Marimo, I was very excited to see. I think you mentioned this explicitly, but they're not stored as JSON, right? They're actually .py. They're Python files, Python scripts, so they are executable as pure Python, which I love. The other thing I would love your thoughts on is a lot of the time when I build data power products or workflows, I'll switch between scripts and notebooks, you know, because this whole scripts versus notebooks thing, like it's been such an unproductive flame war for so long. But my general workflow is when doing experimentation or exploration, I'll work in notebooks. And when trying to serve things to prod, I'll work in scripts, right? But what I'm hearing here is that perhaps we've found a possible middle ground, right?
Yeah, so Marimo does blur the lines because first and foremost, we store everything as a Python file. And that Python file is also, you can import that Python file and reuse it as like a regular Python module. And we take care to store your code in a way that if you import it, it's not going to just run your notebook. Like it'll only run it if you run it from the command line. So you can import it and then you can pull out functions and classes. So you can say from my notebook, import my function or import my class. So hopefully to encourage folks to use that feature instead of just copy pasting cells across notebooks into untitled 6666. Um, So we do, I guess, blur the lines between like traditional, just a regular Python module and a notebook. Um, that said, like I think every tool has its place, right? Like I would say Marimo is great for, yes, definitely exploring data, experimentation. Also, every Marimo notebook can be run as an interactive data app. So we have like the really rich ecosystem of like interactive widgets that work without callbacks. So then you can also use your notebook should you want it to as this interactive data app without like porting it to like Streamlit or Dash or any other tool. So you get that for free. You can run it as a script, and that can actually be really helpful for like these like data engineering style like workflows, where like I think the observability you get, I mean, it's a certain type of observability you get by working in a notebook where you can see actually visually um like you get a record of like intermediate steps in a workflow. So like you can actually like prototype and actually totally build your pipeline or in a notebook, and then the notebook view lets you see what's going on while you build it, and then you can run it as a script from the command line. Um, we do support actually we have a concept of like testing notebooks. So like PyTest can like pick up functions that start with test underscore, so you can harden them in that way. So we go a long way of like making existing things people do in notebooks, which I think is interactive exploration, app-like things, and like data engineering workflows type workloads would make a lot of those a lot more reproducible and reusable. That said, like I wouldn't advocate building, entire software applications out of a collection of Marimo notebooks. Like I think you can take this, and some people have taken this idea like to like really interesting places, like this idea of literate programming and NB Dev, where like I think in that community you do use their framework to just build regular software. That may not necessarily have to do with data. And I hope I'm not misrepresenting, but that's my understanding. And I think what they've done works for their users. We're not pushing really in that direction. Like I still use regular Python to develop Marimo, right? I'm not developing Marimo itself in Python notebooks, if that makes sense.
That makes a lot of sense. I'm interested in, we've mentioned the term reproducibility a number of times, and I think there are several levels of reproducibility, right? So how do you think about reproducibility, and what's the base level of reproducibility that you think we need, and where can we move from there?
Yeah. So I think there's several levels. There's a few kinds that sort of that I think are really the base level is that like in a notebook environment at least, the code on the page should match the outputs you see. And if it doesn't, that's when you can get into all these sort of like issues where like there was a study that like from 2019 that like pulled down like a million notebooks from GitHub and tried to rerun them and found that only 25% of them could even be run, and only 4% of those, like when you ran them, reproduced the outputs that were previously serialized in them, meaning the code on the page didn't match the outputs you saw. So I think that's like a huge problem for a tool that's supposed to be used for like science. So that's like base level runtime type of reproducibility. And the way the Marimo tries to solve that is with this data flow type structure it imposes so that if you run a cell, it runs dependent cells, or if your notebook's expensive, you can configure it to mark the other cells as like stale or lit. So like you get visual indication that, hey, you need to rerun the cell. So that's one level. The other level is like third-party dependencies. Like I think it's really common, especially for like these kind of like data exploration or even model training workflows to just want to get like an artifact out as quickly as possible. And you might not be as disciplined of like, setting up like a PyProject toml and like recording your dependencies. But that's a problem because then when you share some with a notebook file, they're like, well, what do I need to install in order to get this to work? Um, so one way we solve that is actually by tightly integrating with the UV package manager, which is a new package manager that I guess the broader thing is it's a package manager that supports new Python standards, or I guess Python standards like PEP 723 that allows you to inline your script metadata and your package dependencies in your Python file header. Marimo notebooks are just Python files, so we can put that header in our notebook, so that if you run Marimo with a specific flag, when you install packages through our UI, it's just saving them directly in the notebook file. So you don't have to even think about it. And then you share that single PY file with someone else, and Marimo will create an isolated virtual environment for you, install those packages, and you're good to go. So that's like two level on like the sort of that we can address like with like a single sort of tool like Marimo itself. But I think there's like many other kinds of reproducibility that we don't yet address. Like we talk about like data workflows, right? Like I think one thing that's really common, and I've seen some tools, address this in interesting ways. Like you run some data pipeline, it fails. Fail if things always fail, right? So it fails for whatever reason. And you want to figure out why it failed. And step one to doing that is like finding a way to rerun it, right? Um, but sometimes if it failed in the cloud, but like the setup in the cloud is like different from what you have locally, so it's like hard to reproduce locally. Maybe you didn't like snapshot the data that was used, that was fed through the pipeline, so like you might not even have access to rerun the pipeline with the same data that triggered the failure. And I think like what people often do in practice, because these things are hard, is that like okay, it failed in production. I don't have access to the exact data, but let me try and sort of recreate it. Okay, it seems kind of good. Push it up and like kind of hope it works. I think that's like a huge class of problems that that would be interesting to solve for, and some folks are trying to solve it.
Um, that's super cool. I am interested. So we have, of course, the order of execution and the ability to reproduce a notebook when shared with others. Reproducibility of data being introduced. Package management story incredibly important, and UV, of course, is another thing that makes me feel old. Just joking, but UV is incredible. I mean, it saved us from a lot of. I mean, with every now and then things tend to break down, and we end up in dependency hell as a community and an ecosystem, and things slow down. And UV has kind of brought back all the wonderful things that Pip used to be capable of, but made it blazing fast for us in an ecosystem which has a lot of bloated packages as well. To a lot of great packages, but there's a huge amount of bloat also. Um, I'm interested also if we're thinking about reproducibility. I love that you have some lazy characteristics and things that aren't computed if they're too expensive for some definition of expensive. I wonder if you've thought about reproducibility of compute or being able to have cells attached, even via decorators or something like that to particular compute infrastructure, so we can introspect into that after the fact.
Yeah, no, I love that idea, and it's something we've toyed around with in like the ideation phase and the whiteboarding phase. Um, we haven't like worked on that in particular yet, but the idea, and some of our users have kind of said, "Oh, wouldn't this be so cool if you could offer this to us?" Of like why does a notebook have to be tied to a particular compute infrastructure, right? Like you think about like Databricks notebooks, for example, and they're awesome. It's an amazing product and it serves so many industries. But it's like you start your notebook on like a Spark cluster and like whatever, and that's kind of it. But like what if, you wanted to do like write some kind of program, and maybe you're interacting with it in a notebook that like did started with some analytical queries, right? Maybe it hit some OLAP engine. It could be anything. It could be Spark, it could be DuckDB, whatever. It could be local, it could be remote, but does some OLAP queries, collects all the data, maybe visualize a little bit, and then trains a deep learning model, maybe on a Ray cluster or somewhere else, right? Um, and like seamlessly all within like what feels like the same program in the same interactive environment. I think that'd be really powerful. And whether it's like on a decorator level, or like on a cell, or whether it's like function based, I think these are all interesting ideas to explore. And folks are exploring it in like, I think, in like we talk about the landscape of tools. I've seen ideas like this explored in a variety of different ways. Like obviously there's like the resurgence of like serverless functions and like companies like Modal that let you like run a function on like remote hardware, and you specify like the image that's used, the container image used to run that function. Similarly, there's like Coiled, like the company behind Dask and their coiled functions, which is a similar concept, but like in your own cloud. Um, Runhouse is another company I've seen, or open source project and company uh, that also has this idea of like, I think they talk about themselves as something like the PyTorch for like PyTorch sensibilities for like ML infrastructure. But the idea of like you have your functions and they're the first class thing and you specify where they run and it's kind of decoupled from compute. Super compelling ideas. Something that we haven't built out for yet, but that's sort of that we're actively thinking about.
Yeah, yeah, I love it. And one of the reasons that just the decorator paradigm or mental model came to mind is, I worked with the Metaflow team for years and out of Netflix, and that's how they approach their data-powered machine learning AI workflows, where you have steps and you attach different decorators, so you can assign different types of compute. And once again, that was AWS native because Netflix was so AWS native. I think few people actually know or recognize that I think for a significant amount of time, Netflix was like the biggest consumer of AWS, even before Amazon itself was, right? And I think my understanding is that, being that consumption like powered a lot of the ability for AWS to scale the way it did as well. Actually, but in Metaflow, the ability to assign different steps, I can use Metaflow and do steps locally. And if I need some batch or like GPUs or whatever, I can just send it, to AWS or wherever it is now. Super cool and increasingly important with all the generative AI stuff we have to do today. And that actually brings me to another point. For better and for worse, I love vibe coding, man. I love it. And I'm not gonna, I'm not gonna build the next SaaS product and kill industry with it, like all the linked influencers want to rail against old men screaming at clouds. But one of my favorite things to do, actually, because I work on a lot of LLM powered software, is to vibe code like custom JSON viewers so I can annotate my own data and all of this type of stuff. Super fun. But a serious issue I've come up against, like I could probably list 10 serious issues I've come up against, to be honest. But one is the inability of even um, uh, the best tools and pieces of software to help me vibe code in notebooks. And I know this is not quite vibe coding, but something I've seen in Marimo is the ability for you to chat with an AI assistant in your notebook, which is super cool. So I'm wondering how you're thinking about the future of being able to have, an AI agent help you code in a Marimo notebook.
Yeah, definitely. I mean, I think like you mentioned, these tools are so ubiquitous now, and then like if you're building anything that resembles um, a programming environment IDE like thing, you kind of have to have um, some kind of large language model assisted coding. And so we have a bunch of or we integrate LLMs in a variety of ways, but I think at a high level, I think what's interesting about the notebook or like the data sort of world is that like I think the way you use LLMs is also like kind of different from like how it might be used by a software engineer working in Cursor, for example, right? Because like if you're in Cursor or building some kind of software that doesn't have this data component, like yeah, Cursor is going to go in, look at like all your huge, your repo, pull in your code as context, start jamming. I think what's interesting about the data space, and especially notebooks, is that like um, you have data in RAM, right? You have it in memory, and like you can provide the variables in RAM as context to your large language model, right? And so that it can start actually doing, like you mentioned, like agentic like things and start coding for you against the actual schemas of your data frames, the actual values of their columns. And like so like one small example of that, but I think it's pretty powerful, like in our sort of integration with large language models, and you can like tag like your data frames, for example, that you can say generate a plot of at my data frame, um, column X versus column Y, faceted by whatever, and it'll then behind the scenes will read like, the column names, maybe the first five values, put that into the context of the prompt, and then like help the LLM code against it. And so, and then that's not even full on agentic. That it's like one step, but I think like even that one step thing of read the data in, give it to the large language model as context, and then iterate on that, I think is pretty powerful. Um, and yeah, I imagine it, as I think many people do, as a mix of, you know, use the LLM to write some, boilerplate code that, I always forget the syntax of whatever plotting library I'm using, and it's nice to be able to accelerate that. And then when I don't know exactly what I'm looking for, and actually, if I actually need to kind of like touch the data myself, then I'll be manipulating it with code directly. Um, yeah.
I love that example. And sorry, my mind's going in several directions. The first is kind of like df.head. And now I'm going back to pandas, right? But like when I start exploring data in a notebook to get a sense, or sitting there with a colleague, pairing to get a sense of what's up, look at it, chat about it together. Um, I do when I work in Cursor or Continue, I do say, hey, let's explore the database schema together, and then have a look at some of it and see what's up there, which I think is incredibly important. It comes down to another thing that I think anyone who's getting started with vibe coding, or even if you're a bit more seasoned, you probably know this, but plan with your agent. Don't execute immediately. Now, of course, when you try to plan, it'll try to execute. Like that's actually another huge failure mode is you're like, let's talk about this. And it generates like five subdirectories, each with 7 files of 1,000 lines of code each or something like that, right? And Cursor's not as bad as, Manus or Devon, but these are pretty serious failure modes. But if you like develop a spec, who would have thought writing a product spec would help? Half joking, but if you do this with your agents, it can help a huge amount as well. Um, I'm also interested, Akshay, into it's not quite to do with reproducibility, but it's a very important part of kind of the holistic story here is observability. And I know you've started thinking about, being able to show traces of what's happening and have an inspector of all your variables in Marimo. And by the way, everyone, we're going to have a demo at the end where we'll show a bunch of these things, I hope. But yeah, I wonder how you think about monitoring and observability as a part of this story you're trying to tell as well.
Yeah, I think that's a great question. I mean, so there's all kinds of levels of it, I guess. There's from the most basic of like logging, Python logging module to like having traces of execution. Um, for interactive programming environments, and it's interesting because like Marimo is a notebook, but it's also usable as a data app, and it's also usable as a script, which implies, and we're working on features to sort of upgrade from usable as a script to usable as a pipeline. So there's different kinds of observability you kind of want in like each of these different modalities. When you're working in the notebook, like exploring data, interactively querying with Python or SQL, then yeah, the variables panel that we have is very helpful, I think. We have like a trace of like how long each cell took to execute, which is also helpful. Um, when you're running as an app, typically then you just want like traditional Python style logging, right? And which, it's just a Python file. You can just use logging and it works as sort of expected. When you run as a script, that's sort of what, or a pipeline, that's when it starts to get pretty interesting because like again, we talk about like when you run pipelines, they fail, and like the kind of observability you want is the kind that kind of helps you diagnose why something failed. And I think there's like a lot of things that we could do there that we haven't really pushed on too much yet. Um, but for example, like I think like Vincent Warmerdam actually, who's also a member of the Marimo team, has this really cool Python package called Flowshow that like lets you sort of um, put together like a little pipeline of composed of functions, and it'll like trace the execution of the functions and show you like how long each one took to execute, and also if something fails, like it'll like show you sort of where the failure occurred. But I think like at least what I imagine for pipelines that I would really like in terms of like observability in this fashion would be like you run your notebook as a script, and maybe we help you parallelize some of the work in it, and we help you with like checkpointing state, etc. along the way. But you run it as a script or a pipeline, and you get like a visual record of each cell output, right? So you get to see like, okay, like that gives you like just like ad hoc, like, okay, does this kind of look, does this pass the like, is this reasonable test? But then also you get a record of like how long each cell took to run, where it pulled its data from, and things like that. And you get like basically like a whole I guess packaged artifact that like completely describes that workflow run. Um, this is something that's in the ideation phase, but I think that would sort of complete our story of observability across the interactive notebooks, apps, and like script/pipelines.
Incredibly cool, man. And I've actually just linked to Vincent's video on called New. It's from Marimo's YouTube channel 2 weeks ago. New tools to inspect the flow of Python code, where he's demoing Flow Show. And I mean, follow Marimo's YouTube channel. Follow everything Vincent does as well. He's one of the most thoughtful and interesting and fun people in the space. A lot of this, I'm even sounding serious while talking about it. Everyone's so serious, and Vincent's a serious Dutchman to be sure, but he's also like a deeply playful, interesting human who reminds us the sense of play with all these tools and how interesting they can be as well. So that's super cool. I just do want to step back a bit, and we are in a space. One thing that I love about the Pythonic data landscape from, from PyData and SciPy onwards, and to what's happening with LLMs now is how how important the hacker mindset is, and composability, like some old school Unix stuff, right, man? Like pipes and just joining everything together and seeing what's up, plumbing. And one thing I love about Marimo is how it integrates with DuckDB on one end, and then on another end with Pyodide. And I've actually just linked to Pyodide's blog post about Marimo. And I'm just wondering if you could give us at least I know it's too much for one a segment of one podcast recording, but a brief introduction to like all the tools that Marimo integrates with, and where they sit in the landscape and what people can use them for.
Yeah. Oh, I love that question. Let me try. That's a good question. Um, okay. So there's a bunch. And so, okay, like I mentioned, Marimo can be used as a notebook, as an app, or as a script. All three things sort of all three sides of the same three-sided dice. I don't know.
I
I don't
like
know.
it. Or a three-sided coin.
Yeah, there you go. Um, You mentioned DuckDB on one end and PyDot on another, and I think those are good places to start. So we put a big emphasis on Marimo being just Python, and it is. All the files are just stored as Python. Um, but at the same time, we recognize that like SQL is extremely important for working with data, right? So we do have like first-class support for SQL in a variety of ways, and but in the UI, you can get like you push a button, you get a SQL cell, and by default that's powered by DuckDB, and under the hood, we write some Python code that contains your query. Um, and DuckDB is a really fast in-memory OLAP engine. So it's really good because it can like actually you can pass your data frame from Python into your DuckDB cell and then run your query, and then out comes another data frame. And so like actually the data flow
Mm.
graph actually spans from Python actually over SQL and then back to Python. And that's something we don't talk too much about, but it's actually we have a parallel data flow graph on your SQL cells. And so that's one end. And DuckDB is the primary interface, but actually, you can connect to all kinds of databases, and you can connect to Postgres, you can connect to other analytical things like ClickHouse or Snowflake. You can connect to like Iceberg catalogs even, and like we show you like a preview of all your schemas and stuff like that. Um, that's one end. So that's for working with data, basically, right? And so when you work with data, there's SQL, there's charts too, right? Plots. So we have like pretty tight integrations with Altair and Plotly, so that like if you output an Altair plot, for example, you can select some data in the plot, and then it comes straight back the selection that you made. So like you selected some points in a scatter plot. You get them back as a data frame in Python. Um, and so that like really lets you like make these like interact with your data that was previously not really easy or possible in previous programming environments. So integrations on the plotting side there. Um, on the front end, I think this is like for like sharing kind of is how I think about it. So like, as a big use case of notebooks is like publishing or sharing your, your work with like text, images, code. There's a few different things. So Marimo, you can run it locally. You can run it on a server and do SSH port forwarding just like you do with like traditional notebooks. But you can also run it entirely in your browser. Like all the Python code gets executed by your browser, and this is thanks to a tool called Pyodide, which is like a port of C Python to WebAssembly. The point is that like you can export your notebook as an HTML file and just some like assets, and then just like serve it on GitHub pages or internally too in some private domain. And this makes it really easy to kind of just get started. Both to get started with notebooks, you can go to our online playground at marimo.app, but also to share like interactive experiences. Like you can embed like interactive notebooks in your docs, for example. Like so like we do that throughout docs.marimo.io, and we have some other folks doing that as well. You can also embed them in like Markdown in Make Docs documentation. We have a plugin.
Mm.
Or in Quarto, we have a plugin for that too. So like you can, thanks to PyDite, it's actually quite easy and quite pleasant to create these interactive sort of Python-based experiences. Um, and then I can keep going. So we integrate with UV Package Manager quite tightly. So that's on the packaging side, and we've talked about that already. We integrate with a lot of the because I think it comes down to because Python Marimo notebooks are just Python files. There's like a long list of the developer tooling for Python that we integrate with like kind of seamlessly, like PyTest, UV, DocTest, and there's more. Um, AI assistants like GitHub Copilot and all your other sort of favorite sort of OpenAI compatible endpoints work with Marimo. Oh, a big one that I should mention that I haven't mentioned yet is AnyWidget. So AnyWidget is I guess, both a specification and like implementation of a way to write like these portable interactive widgets that work both in the Jupyter ecosystem, in the Marimo ecosystem, and elsewhere. And so like we've standardized on AnyWidget as the way to write third-party plugins or like UI plugins, UI widgets. Um, and that really opens the door for folks who do know JavaScript to like really make these truly interactive experiences. Um, and AnyWidget is developed by Trevor Mans, who's this amazing, creative, passionate developer who is joining us full time, I think, in less than a week, about a week. Um,
Congrats.
yeah, yeah, thank you. He's amazing. Yeah. If you look at AnyWidget and look at the work you've done, you can clearly see his passion for building developer tools and things like that. Um,
That's all amazingly cool. You've mentioned so many fantastic tools. I've linked to a couple. I've linked to AnyWidgets. I've linked to Quarto, which I just love, to be honest. Um, I also just something that came to mind while you're speaking is there's such a rich lineage of tools here, and it isn't as though these new tools, emerged out of nowhere and aren't connected to what preceded them. For example, Altair, right? Is I don't know if it's still maintained by Jake Vanderplas, but it was created by Jake and Brian Granger, over a decade ago now. And Jake has been working the PyData and SciPy ecosystem for a long time. Brian is a co-creator of Project Jupyter, right? Similarly, as we've mentioned, people are always like, oh, Jupyter Notebook over IPython, forgetting that not only is it a predecessor of IPython, but it operates on top of IPython as well. IPython is the standard on which it operates. Similarly, people are like, oh, I prefer Seaborn to Matplotlib, absolutely forgetting that Seaborn works on top of Matplotlib to allow you. It's among other things an abstraction layer on top of Matplotlib, right? Which Michael Wascombe, who created it, will be one of the first people to tell you. So there's a rich historical lineage of tools and people building them as practitioners themselves. Nearly everyone we've mentioned are actually have been research scientists for a lot of their careers and built these tools in order to support their own research and those of their communities. One other thing that just came to mind is computation happening in the browser. What type of tools support that, and how do you think about that with Marimo?
yeah. Yeah, it's a wild concept, but
The first time I heard of it, I was like, what? You know?
yeah, yeah. And so that's the PyDide and WebAssembly bit, right? So like
Mm.
with Python being uh compiled or CPython being compiled to WebAssembly via this tool chain called Emscripten. Um, Phenomenal project that came out of Mozilla. And actually, just for a short digression, I mean, you're talking about legacy of rich history of projects. Like there's a quite direct through line at least to the our in-browser version of Marimo, um, powered by PyDide, to like history of PyDide's development itself. So at PyCon we got to meet some of the original developers of PyDide from way back when. Mike, who is now at Microsoft, was working on the Python JIT and all. Yeah, so I mean, PyDide, the ability to run Python code in the browser came from Mozilla with this idea that, they had this project that they called Iodide, which was kind of sort of like a Marimo notebook thing. It was a computational notebook that ran in the browser and that could execute Python in the browser, and it was designed to help scientists, like share their work with others because, they were, if anyone were to realize it, it would be Mozilla that, the web is, the future sort of platform of sharing and, computation that makes computation very accessible. And since then, PyDAT has been maintained, um, I think maybe by several maintainers, but today it's maintained by Hood Chatham, who's a fantastic, fantastic, passionate human being. And what PyDAT lets us do is make it extremely easy to share interactive Python notebooks in the browser, right? Like, so you don't even have to like install Marimo locally if you don't want to, just to like try it out and get a flavor of it. You just open up our playground at marimo.new. And there are limitations, right? Right now, PyDide's, I think, total addressable RAM is like 2 GB or something like that. So you're not going to train a deep neural network in your browser, at least not through PyDide. Um, but what's impressive is that like basically the entire PyData stack works in the browser. So you can run sklearn, you can run SciPy, Matplotlib, all these projects. NumPy, they all just work. Um, and I think you can combine PyDide with 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 caching. So basically, one thing that one of our engineers, Dylan Matasetti, is working on is intelligent caching of artifacts computed in your Marimo notebooks. And so like you can like train some neural network using JAX and some gnarly stuff on your machine, and then store them in some remote cache, say in some bucket somewhere.
Mm.
Um, and then you can share a link to your notebook, like a WebAssembly link. So like the code will run in the browser, but like your expensive code blocks will be like decorated with this cache thing, or you'll use our built-in caching mechanism. But basically you'll be able to pull the computed data from cache, and so you'll actually have the code that was used to train the model. But at the end of the day, maybe you've distilled all your data and all your training code into like some small model, and that can actually run in the browser, maybe through Onyx or something like that. And so that gives a way to actually share artifacts of research and like complete artifact and like entirely in the browser, executing in the browser with the code, just short circuiting actually the computationally heavy code.
That's super cool, man. Um, can't wait to play around with that type of stuff more. And I wonder the 2 gig limitation, is that hard to work around with a Pi? Because the type of stuff we get with like consumer grade I haven't said this publicly, I don't think, but I just got a new laptop. I got one of the like M4 Max with 128 gigs of unified RAM, bro. And it
Yeah.
like I was able to one of the first things I actually vibe coded at Gradio. If people haven't played around with Gradio, it helps you build like simple UXs, UIs for ML AI stuff from Hugging Face. The first thing I did was downloaded Olama and got like pulled 10 models and spun up a Gradio interface with a whole bunch of 14 billion parameter models and able to run a single prompt and in 10 to 15 seconds see the outputs of all of them side by side, man. So I'm really giving this laptop a workout. But with Pyodide, it could be exceptional. Do you know if that's something that would be difficult to to get up and running?
I have seen discussions their GitHub in their GitHub repo from some time ago. I honestly don't know the details. Um, I think it's certainly possible, and there's discussions there talking about how they would do it. I think
Mm,
it's more of a matter of having people staffed full time to work on it.
absolutely.
Yeah, it does sound, I'm sure, like a hard technical problem as well, but
Yeah,
the one thing that I've been noticing with Pyodide is that it just keeps getting better, like, and it kind
totally.
of inevitable, and like, so I imagine it'll be lifted in the future if I were to just guess, just the way that these things go, and like, there's like promising like demos I've also seen, right? Like, um, even outside of just like RAM, like leveraging WebGL to like actually have like GPU accelerated code as well. Um, And so like if I imagine like the future of Python in the browser, I mean I personally would love it if yeah, you could seamlessly use WebGL to run your torch models and yes, if you could lift that limitation on RAM, that would be amazing. Um, I expect to continue to see uh, great sort of progress in that sphere, especially as I think more and more people will ask for it, right? Like AI is so prevalent today, and like the Mozilla folks kind of recognized so long ago, like the web, the browser is like this common operating system that we all have access to. Um, so I
Yeah,
imagine we'll push on it.
absolutely. And particularly with like, I mean, consumer grade laptops these days are absolutely wild as well, to be honest.
Yeah.
I'd love to jump into a demo in a minute. I would just like to say, and I should have mentioned this earlier when we are talking about Corto. I use Corto to publish my own blog, and I'll link to that in the show notes. But it's a wonderful open source scientific technical publishing system. Has a lot of affordances. You can use it with Python, R, Julia, a bunch of different things. One of the reasons I wanted to mention it and just focus on it for a second is it was built by our studio now Posit, and I do want to say if we got a bit sociological with respect to the builders in the ecosystem, I just want to give a shout out to the entire R and our studio community for over the years and continuing to build diligently. There's more of a focus on Python now for obvious reasons, but huge swathes of people use R, and the way R Posit now is being able to build stuff for Python as well is just absolutely wonderful. So huge shout out to JJ Lair and everyone in that ecosystem in the Tidyverse as well.
Yeah, no, it's an amazing community, and we're really thankful for all that they've developed. Them, the Jupiter community. I mean, yeah, what they've been able to do over a couple of decades is just phenomenal. Because I mean, like you mentioned earlier, and okay, I'll show a demo, but like there's the Jupyter notebook, but people don't realize that's running on top of IPy kernel, and like that's just one flavor of what
Mm,
Jupyter is, right? Jupyter is actually this collection of really well designed interoperable like components of like the Jupyter server, the Jupyter kernel, which is language agnostic, um, uh, and then the front end, which the Jupyter team has made. But there's also other front ends like Colab is a front end for the kernel. So like Databricks notebooks are, I think, a front end for. So it's what they've done is like they've managed to like build this foundation for so many other people to build on top of, which is also
absolutely. Yeah.
uh,
And we didn't actually get into this, but I do. I mean, Jupyter, as you said, is language agnostic, and you made a design choice to focus on Python, and I think that constraint perhaps was helpful in you building something which served particular user needs as well. Is that a reasonable characterization?
100%. Yeah, I think focusing on Python was it does impose a big constraint. It also allows us to do a lot more, like all these sort of language integrations that I've mentioned sort of throughout this discussion. Um, and it is a trade-off, right? Sometimes folks come to us from the R community and say, "Oh, hi, can we get, will you add support for R?" Like that's like really hard for us because like, we have to parse the Python AST. Marimo's not just a notebook, but it's also a library that gives you the UI elements and like a bunch of other sort of powerful features. Um, and so I think like that is a conscious trade-off that we've made, and I think we can develop better experiences for our Python users at the cost of not being able to serve, the R community. And I do want to just give one more shout out to the Julia community, because where a lot of the inspiration for this project came from is from a really cool reactive notebook called Pluto.jl, which took that philosophy of like, we're going to build a notebook just for the Julia programming language. And that it and they ended up with a reactive notebook that really sort of, if you study Pluto, you will see a lot of it sort of uh, it has cast a lot of shadows in a good way. You know, there's a lot of design sort of heritage that sort of influenced us in developing Marimo.
Awesome. So I'd love to jump into a demo. I want to do something a bit out there though, Akshay. I I actually had food poisoning the past few days, and I'm coming out of it now. And a lot of my time in, lying down, I was playing around with Marimo. So I'd like to show you something I did with
Oh,
Marimo.
I love it.
And
Yeah, you go
yeah,
ahead.
and then I'd love to see something you've been playing with. And I'm a bit nervous. Like we've spoken a few times, but I'm no expert with this stuff. But can you see my Chrome
Yes, I can
browser?
see. I can see eigenfaces.py.
Yeah,
I can see
exactly.
that.
Okay, cool. So this is actually based upon an example in your gallery, which I linked to. I linked to it in the YouTube chat. I'll do so in the show notes, and I'm going to talk through this as well, just in case if we include it in the audio in the podcast, so people can check it out. But it's based upon an example where you have the MNIST data set, and you show how you can cluster it and visualize it, and then interact with the clusters essentially. So I thought to do this with an example. It's a facial recognition data set called Labeled Faces in the Wild. Now, I normally wouldn't use a facial recognition data set. I actually see relatively few good uses for facial recognition, but the wonderful people at Scikit-learn have a subset of the data set which only has world leaders in the data set. And I have no problem with doing facial recognition on world leaders, particularly these ones, to be honest. So I'll go through what's happening there. But we have, Chavez and Blair and Bush, Colin Powell, Ariel Sharon, and so on, right? So to get there, what I've actually done is doing our imports. Then I've imported the Faces in the Wild data set. I've got this many 12,000, 1,300 samples, 1850 pixels or features, and 7 classes, so 7 people. Then I've used a FaceNet model, which is a facial embedding model, essentially. And what I've done is I've taken each of the images and used this embedding to embed them. And this is all in this Marimo notebook, okay? As you can see. And then I thought to project down to 2 dimensions using tsne and UMap, right? Now, in Marimo, you can actually do a drop down, but for the purposes of this demo, I decided not to because I want to show you an even simpler version of reactivity here. But you can see I'm using tsne to 2 components to find a few things there. Then I create a data frame of my embedding, and then I use Altair to get me a scatter plot, right? Now, this didn't run because it's not Markdown, I think, and I can easily change that to
Yeah. And then
Markdown here, and
the run button.
yep, great. And I will just, so it's pretty. I will hide the code, right? So what we have, and I love this, man. This is so cool. We've embedded our world leaders where we have, Ariel Sharon there. We have Colin Powell, and I did this in a matter of minutes, right? Tony Blair, George W. Bush, Gerhard Schroeder, Donald Rumsfeld, and up here we have Hugo Chavez, and then we have. So this is actually one of the really nice things. I was like, all of these clusters are really linearly separable, super cool. But we've got one bloody George W. Bush there, right? And I'm like, what is happening there? And so I wrote some code, which I got from you and your demo, which allows me to select this and then scroll down, and it shows me all the ones I've selected, right? So that's super cool. Now, I want to see the George W. Bush one, but I can't. It's Chavez all the way down, right? And there are 72 rows. But if I want to get to the W. Bush one, I click through it. I saw that there. Now I just click on this. That's the one that it thought looks like Chavez. Maybe it's the sunglasses. I don't know. But that's a really beautiful way to interact with my embeddings immediately to see what's up there, which I found super useful. Now, on top of that, let's say I didn't like that because I'm like that doesn't feel good to me. That may actually be a result of my facial embedding as opposed to this projection here. But to test that, I decided to do UMAP instead. So I can now re-execute this cell, right? And it automatically executes that and then will re-execute everything that's dependent on that, following the directed acyclic graph principle, right? Anything that depends on that, it re-executes. And now we have this new embedding, right? Or this new projection of the embedding. So we've got Bush there, we've got Chavez there, super cool. Here we've got, for some reason, Rumsfeld looking like Sharon. So let's just go down and see which one it is. And there may be an easy way to search this, but
Yeah, there's a search button in the bottom left.
oh yeah, great. So okay, yeah. So I'm going to go back to the start. Going to do search and do yo, dude. I can see it. I may not classify it as Sharon. The other thing is, I love how data frames render with these really nice visuals at the top and that type of stuff. But this was all to show, based upon a demo of yours on the MNIST data set. I was quickly able to import my own data set, play around with it, do some embeddings, and see what's up immediately. And I had so much fun doing that, man. As I said, I had food poisoning, and this was this was actually some of the most fun I had in the past couple of days. So really appreciate that, man.
I'm glad we could help you get through your food poisoning.
Totally. And of course, I'd love to hand it over to you in a second, but all of this wonderful stuff on the side, such as, let's see, the variable explorer we saw before, or we talked about before, the Scratchpad I mentioned, the ability to chat with AI and those types of things. So, is there any reflections on that, or anything you would have done differently, or anything I did poorly that you'd suggest to do differently with Marimo?
No, this was fantastic. No, I don't think I would have done much anything differently. In fact, this is a lot. I like this. This is a lot more entertaining than the MNIST demo that I show. And oh, I think I accidentally reacted.
Yeah, at least it was a thumbs up and not a thumbs down. Well, dude, I would if I'd love to contribute it to your docs or your gallery or something like that at some point, if it would be helpful.
Yeah, yeah, we'd love. I'd love to add this to the gallery. That would be super helpful. Um, no, this is amazing.
Awesome, man. Well, why don't we jump in, and I'd love to see what you've been thinking about as well with Marimo. But that was really fun, so thank you for humoring me on that.
No, of course. Sure. Let me share my screen. Um, oh, sharing is not turned on. Send request.
Oh yes, great. Sorry, because I've just gone back to not sharing. I'm seeing some comments by Calm Code by Vincent in the chat, and he says, "Hey, that looks like a bulk labeling-esque demo. Great." And he wrote, "The nice thing about this approach is how general it is. You can embed everything, anything, and the kitchen sink these days, and you can always follow up with tsne UMAP after." Totally agree. And I not enough people know about UMAP and tsne, and so let's definitely spread that word.
Yeah, no, it's a cool project. In fact, my PhD thesis was like a generalization of all these embedding methods. So I spent a lot of time playing with all of these embeddings, and they're really great tools for interactive data.
Yeah. And Vincent actually also mentions the clusters that show up are always informative. And I totally agree. They're either informative about stuff happening in the data or stuff that's garbage in your embedding model as well,
Yeah,
right? So
yeah, yeah,
super
yeah.
cool in both respects. And you have to do the work to figure out what's up.
Yep, yep. And I mean, the way these clusters work, right, they're essentially, if you look at it, they're like k-nearest neighbor clusters. And so it does tell you a lot. Also about the metric you've
Totally.
used to do that. Okay, I can share something. 1 second. Um, okay. And it's good you mentioned Vincent. But actually, this demo was developed by none other than Vincent, who is, among other things, uh, he has amazing capability to build inspiring demos that are
Mhm.
both succinct and just like just so fun to play around with. Um, so this is a Marimo notebook,
And will you
and
be able to zoom in a bit or just make the
yeah,
text slightly larger?
definitely zoom in. How's this?
Perfect.
Okay. So this is actually using our multi-column view. So you'll notice there's two columns of code here actually, and you can enable that in the setting. You can say display with columns. And Vincent likes to do this a lot, actually. I think he's got his logic in the left-hand column and his visual outputs in the right. And this demo is showing how to prototype an LLM assistant in a Marimo notebook, and an LLM assistant that has access to tools. So something that is a lot more lightweight than, say, setting up a MCP server is just Python functions all the way down. So he's using this cool library called Miroscope, which lets you define Python functions and then register them as tools with a large language model. So from Miroscope, he imports this LLM module, and he has this little chatbot that has access to a few different functions. In particular, it can roll a die, which has some number of sides. And again, that's just a Python function. It can remember things that the user has asked it to remember. Um, and that just calls a set memory function. And it can recall things that the user has asked it to recall, that recall things from its memory. Um, he uses the LLM function, the decorator, to create a base prompt for it, and then just a little bit of Python logic here to create the logic for what the chatbot flow should be. Wraps that in this Marimo UI element, mo.ui.chat, that lets you interactively build your chatbot or your agent. So I can ask it to roll a dice. So roll a dice, and it should go. It gives me a number, one. Okay. I can say roll a dice with 1,000 sides. Let's see if this works. There you go, 135. So what's actually kind of cool about this, and it's a bit of a sleight of hand, right? Like, I mean, it's able to, I've got my parameters here, number of sides. It knows to call this particular Python tool, and then passing the value to the Python function here. Um, I can say, remember my name is Akshay. I will remember that. And then I can say, recall who you are talking to. We'll see if this works. It got it. I'm talking to Akshay. And then I think one thing that's compelling about this notebook experience that, Vincent was showing me, is that like it's helpful for debugging. Like things can like really go wrong, right? Um, but what's nice is that we have this function here that shows what the LLM's memory is. So I think like, for example, I can say something like, I don't know, forget my name. And
It,
okay, wait, that didn't quite work, right? So I'll remember that. So we go over and we say, okay, it actually just added forget my name to my memory, whereas instead I actually wanted to evict it from memory. And so like that's something that I would get. Like this kind of interactive experience really makes debugging things like that like a lot easier than if you were just starting in a script. Um, and again, this was totally developed. This example was developed by Vincent, and follow his YouTube, his YouTube videos on the Marimo channel for a lot more inspiring videos like this one. Um, yeah,
that 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 is so cool, man. I love a lot of things about that. I do love the decoupling of quote unquote notebook and UI in the left and right, and in the panels, and how you can do that in a variety of different, do that for a variety of different purposes. I really love the small like visualizations of memory here as well. And I do, I work with a lot of people who want to build agents these days, quote unquote agents, because whatever that actually means. I'm being half cynical there, but I actually often direct people to talk about augmented LLMs. I say let's talk about them first, where you have memory retrieval and tools, right? And one thing I do with people is get them to try to build an LLM that has some form of memory to it as well. And I'm gonna like I usually do that with Radio or something along those lines, but doing it with Marimo now with something like this, I'm gonna try, and it makes a huge amount of sense. I also love the ability, like I'm gonna go away and try to use this to, when building simple agents with tool calls, being able to see the response of the agent, but then visualize on the right the entire tool chain will be super fascinating and interesting. And the ability to introspect there will be super cool. Big shout out to Miroscope as well. And Vincent mentioned he's doing a live stream with William Baxt from Miroscope on Friday.
Yep.
So check out the Marimo channel for that. Vincent has also asked in the chat, can you try something? What if you tell it your name is Vincent too? What happens if you try to recall the name when there are two names in memory? He also says trying to break a tool is a great way to learn it. And then he says, also notice the logs below the chat.
You are Vincent. So it pops from the end, maybe? Oh yeah, very cool. Yeah, so the pencil here. No, this is a lot of fun. I really appreciate also just like how little code it is. It's just like Python functions that are like a couple lines long, and the entire like chat loop is what, 10 lines long?
Yeah.
Yeah.
I mean, that's the type of code we want to write, right?
Yeah. Yeah, no,
It's a
definitely.
nice abstraction layer.
Yeah, less and less. And yeah, this is using OpenAI under the hood and OpenAI API. And what's actually kind of nice is I think we provided it through an environment variable. And Marima has, we had a ton of these little panels, and this one is the secrets panel. So you can, quickly debug, like you may have forgot, like, oh, did I actually provide my API key? And I could say, oh, okay, yeah, I did. Because I think common annoying thing for like beginners is that like just even getting the environment variable into the notebook. And so small things like this, I think, can go a long way. Um,
Absolutely. And is there anything else in the left-hand panel you want to show us
yeah,
briefly?
there's a few. So this notebook is using the package metadata that I was describing. So it's using the integration with UV. So if you click on the Manage Packages button here, you can actually see all the packages and their dependencies that are in this environment. And what's cool is this is like an isolated environment. And actually, the way I'm running this notebook is I think actually deserves some kind of attention, special highlighting, because I basically,
Could you just zoom in on that as well?
yeah. Oh, that might have my API key in it because I was lazy. Hold on. That's all good. If I bring this here, I'm gonna just create a new cell and do it here. So this is the command that I use to run this notebook. And so we have Marimo edit, UVX is going through UV. And what's cool is that this is actually just a link on GitHub. So Vincent shared this notebook with me as a GitHub gist. I can go here and look at the source code, and you can see it like bootstraps itself with the dependencies that are just inlined here. And I
Oh,
think that
cool.
like just makes sharing like these examples just a lot easier than it was before. We had to clone a repo, go to the see if it had a requirements txt. Like this just like works out of the box. Um, and I think that was really powerful. In terms of other things that I would highlight here, I think in this context, I mean, obviously, so we do have you can chat with AI if you configure your notebook to have your API key. Um, Small things like this live docs, I think our users really like this. It's like basically as I move my cursor, I get the documentation of whatever symbol I'm looking at, like on the
Hmm.
left. And so this is just like almost like a documentation copilot or something, if you will, that kind of just like helps you know at a glance of like, how to use the APIs you're using. Um, yeah, I think those are the main ones. Another one, this might not take effect here, but I really like this panel. It's called a data sources panel. Um, and so if you have any data frames or database connections in your notebook, and this is Marimo's package installation UI, just installing a package real quick. They'll show up in this data sources panel on the left, so you can also have that as a little sidecar, just like at a glance, like what is the data you're working with in your notebook. You'll see here now I have this data frame called cars. I can click on it and kind of see at a glance like what its columns are. If I had Altair, I can try this. Add Altair, and then go back to the data sources panel. Okay, maybe I have to restart my notebook here, but you can get like a little chart preview of your columns. And I think this is super, super helpful of like just like knowing what data you have available and like remembering like what you're actually working on and like because I think
Amazing.
yeah, and work like this data is should be the primary object that you're thinking about. So it's great having it all in
And
one place.
and Vincent did just comment that the auto install when you import, that's the bee's knees, is what he wrote.
Yeah, no, it is a really nice quality of nice feature that my co-founder Miles added, and Miles also did the integration with UV and integration with Pyodide and a lot of other really cool features that we have. Um, yeah, I think those are
Incredible.
the main things
And
that I
all of
did.
those things, once again, speaking to the lineage, I almost hesitate to say this, but some of the things you just showed, like being able to explore your variables in your IDE and that type of stuff, are things that I used to love in MATLAB back in the day, right? That I missed in Jupyter Notebooks originally. I loved in Studio, then I loved in Jupyter Lab, right? So you're really bringing together a lot of the different things that I want as well in my computational infrastructure, man.
Yeah, no, I think it's just like, it's funny, like when you work on new things, I think people kind of forget like tools aren't developed in a vacuum, but like it's the lineage of everything that comes before you that enables you to to make something new. And really it's just like taking ideas from a bunch of different projects, seeing what worked, what didn't, and just remixing them in a slightly new way. And I think that's how new things are made. And you will always see that history of all these other tools that came before it embedded in each new project.
Totally, man. So we're gonna have to wrap up, but I'm wondering, how can people get involved? Of course, we've linked to the gallery. We'll link to the docs. You have a Discord. What are good ways for people to get involved with Marimo and the community?
Yeah, there's a few ways. I think first and foremost, uh, first you got to try it out and see if you like it. And the easiest way to do that, so you can pip install Marimo or UVX Marimo tutorial intro. But really just go to our GitHub repository, github.com/marimo-team/marimo, which has all the instructions of sort of getting started. Discord is where our community is most active. You can get a quick link to it at marimo.io/discord. We've got a bunch of folks in there chatting about all things related to notebooks, data, AI. It's kind of a hodgepodge, and it's just a fun place to be. YouTube, definitely. Check out Vincent's YouTube videos, both for tutorials, but also just inspirational, like demos that really should like at least open my mind of what you can do with a tool like Marimo. Subscribe if you like it. We're on all the major social platforms as well. Um, yeah, I'd say. And I guess the last thing I'd say is we are really open to community contributions. So we have over 100 contributions or contributors to our GitHub repo. Um, and we love hearing feedback. So even if you're not comfortable making a contribution, we love to hear from you, like in our GitHub issues or GitHub discussions or Discord. Um, so please do get involved. Yeah, we're very welcome.
Absolutely. And if you're not comfortable like making a contribution as well, like documentation, even if you notice a typo or something, these are beautiful places to start. And don't forget, if you like using Marimo, give it a star on GitHub as well. One final question, Akshay. I'm interested in kind of what you'd like to see people in the space do more of. What would you like to encourage people to do more?
To do more of. Okay, that's a really good question. Um, uh, let me think.
Yeah, take your time.
Yeah, I think maybe this goes back to where our conversation started about like this sort of new next generation of tools. Um, but I would like at least like tool developers to be opinionated in the tools that they make, uh, and to like really lean into like particular use cases or particular types of users. Like you mentioned, like how we really zone in on Python users, and I think that's really unlocked a lot of benefits. Um, there's a really cool like company I think called Bowplan that makes it easy to write data pipelines as code. And actually they have a lot of similar design philosophies as us, except they have no notebooks and sort of in their tool, but they have this concept of writing pipelines that take uh, iceberg tables in and then iceberg in, arrow out, arrow in, arrow out. And it's like super simple, super beautiful, easy to understand, and just a pleasure to use. Um, being opinionated and making declarative tools so that we can free up our minds from how to do things and rather what we want achieved. And I guess that is the whole zeitgeist of the modern AI era. And so, yeah, I'd like to see that not just through AI. I mean, it's an amazing thing, but also in the tools that we make for humans.
Mm. Yeah, I
Yeah,
love it. So be opinionated and maybe make tough decisions around what you're trying to do as well. Don't try to solve everything.
yeah,
Yeah, and be human centric. And I'm also a huge fan of Baoplan. I'm old friends with Jacopo and Chiro as well. Super
it's a
cool
very
guys. Yeah, building lots of fun stuff. So Akshay, I just want to thank you for all your work in the open source space and for your generosity in coming and sharing your wisdom as well. Really excited to see what happens next with Marimo, and excited to meet in person at SciPy in, just under a month and a half or something like that. And
yeah.
if anyone's going to be at SciPy it's in Tacoma near Seattle in Washington State, come and say hi to myself and Akshay. I'm giving a workshop and a talk. Are you presenting anything there or?
Giving a talk, yeah. Overview talk on Marimo, yeah.
Amazing, amazing. Well, come to his talk, my talk, and my workshop, and we can get together and see what's up in Tacoma. Thanks everyone for joining, and thanks once again, Akshay, for such a wonderful chat.
Thanks so much for having me, Hugo. It was a real pleasure.